Hello everyone. The subject is operating system and the topic is process scheduling. My name is Vishal Choudhary. I am working as an assistant professor in Department of CSC, AKGEC College. Now, the content what I'm covering today, the first topic is what is CPU scheduling. Next is what is important in our CPU algorithm, scheduling algorithms. Now, the first one is the what is the CPU scheduling, why we need it. Next, the third one is the CPU scheduling algorithms. There are two algorithms currently. First come, first serve, FCFS, and round robin. These are the topics that I will be covering today. Now, first understand how CPU scheduling works. Let's say when a process comes from secondary memory to main memory, there are two memory areas. This is the secondary memory. This is the main memory, and this is the CPU. So when the process comes up from the secondary memory to main memory for the execution, so before going to the CPU, it will see the schedule algorithms which process will go to the CPU first. Let's say we have a n number of processes here, n5, p1, p2, p3, p4. These are the processes. So we apply some algorithm here that which process will go to the CPU first. Now, at this stage, when the process starts execution, it will go to the ready queue. Then, if there is no requirement of any resource or any input output, it would directly go to the CPU and then complete execution. But what if there is a need of any input output request? Input output anything like a input output device or any device, external device. So it will go to the input output queue. It will wait once the input output will be available to that particular process. Possibility is there ki time slice expired, but it will before going to the CPU or while going for the execution. Let's say time is we have a 2 millisecond, so it will expire. Possibilities are there, then it will go again to the ready queue for their number. Third possibility are for ka child. This again a system call process for ka child. Next is the wait for an interrupt. Interrupt may be possibility a signal. So these are the possibilities. So if anyone occurs, it will again go to the ready queue and then go to the CPU and then terminates completion. Now next is how is the OS decide which of several tasks to take off a queue. These are the tasks. These actually are tasks. Scheduling deciding which threads are nothing but a part of a process or a program are given access to resources like any input output device or a file or anything like this from moment to moment. Now some assumptions about scheduling. Scheduling, as we all know already, scheduling क्या होती है, ठीक है? Nothing but to decide which process will be given to CPU first. These are the processes in the main memory. Right? This is a CPU. So we'll schedule on the basis of an algorithm, either it is a FCFS, first come first serve, or a round robin, that will go to the CPU first. Possibly P1 first, then P3, then P2, then P5, then P4. This is nothing but a scheduling. Now, since CPU scheduling is a big area of research in early 70s, from 70s only. Yeah, research is still going on. Now, some assumptions for scheduling are as in like one program per user, as we can say ki a user can execute only one program, but this is just an assumption. One thread per program. Program is nothing but a process in execution. Program in execution is a process, or a program or a process can have multiple threads. So it is saying one thread per program. This is just an assumption. Programs are independent. Possibilities are there. They are not any inter-process communication. right? Now, these are some unrealistic but simplify the problem. That's true. These are some unrealistic assumptions, but yeah, true. This can simplify the scheduling problem. Okay. Does fair mean fairness among users or a program? If I run one comparison job and run 5, do you get 5 times as much CPU? Maybe yes. Possibilities are there. So CPU time to optimize some desired parameter of system. Which parameters? Parameters like improper request, resources, and so on. Assumptions. This is the most basic one. How a CPU burst works, or how a process gets the CPU and execution starts. So when a process gets the CPU, it will go like a CPU burst, input output burst. Input output burst means some input output request, wait for that particular request, and then go for the CPU again. So a cycle of a process, execution of a process goes like a CPU burst, input output burst, CPU burst, input output burst, CPU burst, input output burst, and go on. Every process cycle, execution cycle is like this only. Like load store, add store, read from file. Now then when process going for the input output burst, it will wait for some input output request. Input output matlab some device. Like then store increment index, write to file, maybe writing to a file, then again going for the input output burst. This one now waiting for the some input output device. Now third one is the load store, read from file, something going on. So this is the execution of a process. The same one. Now execution model alternate between burst of CPU and input output. I already told you a program or a process actually between only CPU burst, CPU input output, CPU input output, and so on. Program typically uses a CPU for some period of time, then does input output, and then uses CPU again. Like a CPU input output, CPU and input output. Now, each scheduling decision is about which job to give to the CPU for use by its next CPU burst. This is about the scheduling algorithm only. Which CPU will get which process will get the CPU next. With time slicing nothing but a time frame. Like let's say time slice is already given in the process. Time is equals to 2 milliseconds. So after every 2 milliseconds, there is a context switching. The control will given to the next process. Let's say process P1 is executing in the CPU for 2 milliseconds. Then there is a forcefully preemption of the process P1, and the control will given to the process P2 for the next 2 milliseconds. So this is the basic idea about the time slicing. Thread may be forced to give up the CPU before finishing the current CPU burst. I will told you, like here, P1 is forced to give up the CPU, and the control and the CPU will go to the P2 now for the next 2 milliseconds. Now, what is important in a scheduling algorithm? Let's see. It can minimize the response time. Now, what is the response time? The first time a process will get the CPU, it is its response time. Let's say this is a time slab. It is 0, 1, 2, 3, 4. And the process P1 arrives at arrival time. When it is arriving in the main memory, arrives at arrival time 0. Okay, initially only 0. P2 arrival time is 2, and its burst time is the CPU time we are talking about, and the burst time is 2. It is 2, right? So the process P1 arrives at 0 and get the CPU for the next 2 burst time. Process P1. Now P2 arrives at 2 only and get the CPU. So if we see their response time, so for the P1 response time is nothing but 0 only, and for P2 response time is 0 because it is arriving at 2 only. Let's say there is a one more time slab 5. Now process P3 arrives at 2. Process P3 is also arriving at 2 time, right? But it is getting the CPU at 4, right? So the response time for P3 is 2. So the importance of scheduling algorithm is just to minimize the response time, right? Response time is what the user sees actually, right? Time to compile a program, real-time task must meet deadline imposed by a world. Right. Next importance is maximize throughput. Throughput is nothing but the jobs per second. How many jobs can we do in a particular time frame, a fixed time frame? It is a second, it is a minute, it is an hour. So how many jobs can be improved or how many jobs can be complete in a fixed time frame? It is nothing but a throughput of a job or a system. Like throughput related to response time but not identical. Maybe it is related to this one, but these are not the same one, right? Minimizing response time will lead to more context switching. Context switching is nothing but these only. First P1, P2, let's again P1. So this is nothing but the context switching here. All the now the control will given to the process P2. Here the control will given to the again process P1. This is nothing but the context switching. So if we want to minimize the response time, undoubtedly it will increase the context switching. True. Then if you maximize only throughput, but you have to see for throughput only. So these are the related one only. If we minimize the response time, it will increase the context switching and it will maximize the throughput only, right? Minimize overhead, context switch time, as well as efficient use of resources like memory, CPU, disk, and so on. Maybe some other resources, printer also, maybe some other external device only. Okay. Now fairness, it is nothing but the shared CPU among users in a say some equitable way. There is some common rules for sharing the CPU for each program, not just minimizing average response time. It should be not like this only. Now the first algorithm, the first scheduling algorithm, that is the first come first serve, FCFS. This is the important one, or it is really a very simple algorithm, बहुत simple है, simple to implement. As the name suggests, first come first serve, it will work on a FIFO algorithm. What is a FIFO here? What is a FIFO here? Full form of FIFO is first in, first out. The process that will come first will go first out, or we can say run until done. If a process P1 with a maximum, or we can say the large burst time will come first, so it will not leave the CPU until it is done. Here we can see P1 with a burst time 24 comes at first, so it will not leave the CPU until its burst time completed like 24 seconds or whatever it is, right? This is the algorithm. Now in the beginning, this means one program runs non-preemptively until it is finished. Now there is a term non-preemptively. What it is? It will not leave the CPU before it's finished, right? It will not leave the CPU in between until it is finished, including any blocking for input operations, whatever it is. Now, FCFS, the first come first serve, means that a process keeps the CPU until one or more threads block. ठीक है, वो CPU को नहीं छोड़ेगा, it will not leave the CPU. Now see the example here. Three processes. Now we have three processes in the main memory in order P1, P2 and P3. Process P1, process P2, process P3. Now P1 with the burst time 24. Now what is the burst time here? Burst time is nothing but the CPU time. For how many time the P1 will get the CPU? It is a 24. P2 burst time is 3 and P3 burst time is 3. These are the CPU time of P1, P2 and P3. Now draw the Gantt chart and compute average waiting time and average completion time. Now what is the Gantt chart here? It is nothing but showing the process in a timeline. Is nothing but the Gantt chart. We will see later. Now solving the example now. Example is the same. Process P1 with the burst time 24, P2 with the burst time 3, P3 with the burst time 3. Burst time is nothing but the, let me write here, CPU time. Right. Now they are arriving in the order P1, P1 comes first, then P2 comes, then P3. Right. This is the Gantt chart. Now draw the Gantt chart now. This is 0. Initial time is 0 only. Okay. Now P1 arrives first, so P1 will get the CPU. For how much time? Since it is a non-preemptive algorithm and its burst time is 24, so the CPU, it is taking the CPU till 24. Right? Now the next is P2 with a burst time 3. Now since they are arriving at 0 only, but in order P1, P2, P3, and it is a non-preemptive algorithm, so P1 get the CPU first. Now P2 waited to 24 to get the CPU. Now the P2 burst time is 3. Here at 24, P2 gets the CPU for the next 3 seconds. P2. Now the time is 24 plus 3, 27. Right? Now at 27, CPU is free now. Now P3, which is already arrived at 0 only, waited till 27. Now P3 gets the CPU for the next 3 seconds since its burst time is 3. This is nothing but the Gantt chart. Now we will see the waiting time here. What is the waiting time? See, for the P1, it is arriving at 0 and get the CPU at 0 only. It doesn't wait for a single second, right? So the waiting time for P1 is 0. Clear? Now see, P2, it is showing 24, which is very large waiting time. See, P2 is also arriving at 0 only, but waited till 24. So the waiting time for P2 is 24. Right? Now see the waiting time for P3. P3 is also arriving at 0, sorry. P3 is also arriving at 0 only, but getting the CPU at 27. So it is waited till 27th millisecond or second, whatever it is. So waiting time of P3 is 27. Now see the completion time. It is nothing but the waiting time plus burst time. The formula for completion time is nothing but the waiting time plus burst time. Right. Now see the completion time now. For P1, the waiting time is 0 and the burst time is 24. So for P1, the completion time is 24. Fair enough. Now for P2, see the waiting time. Waiting time for P2 is 24. It is waited from 0 to 24 seconds, right? And the burst time for P2 is 3. So the completion time is 24 plus 3, 27. Right? Now see the waiting time for P3. Again, it is nothing but the completion time is nothing but the waiting time plus burst time. For the waiting time for P3 is 27 and the burst time is 3. The total time is 30. 27 plus 3. Now see the average waiting time for all these processes. Since average of process P1, P2, P3, so it is 3. Now waiting time for P1 it is 0, 24, 27. So how we can calculate the average sum of all these divided by number of elements, like it is here, it is 3. So it is nothing but 0 plus 24 plus 27 divided by 3, it is 17. So the average waiting time for each process, we can calculate the average, it's like 17. Now see the average completion time. For P1 it is 24, for P2 it is 27, for P3 it is 30. Now the average is nothing but summation of all this divided by 3. It is 24, 27, 30 divided by 3. It is 27. See, it is really a large number. If we see the average waiting time for 10,000 processes, it is showing me 17. And the average completion time is 27. Next. Now we are doing nothing, just changing their order. In the last example we have seen, the order was like P1, then P2, then P3. At the same time instance, they are arriving in this order only. What if I change the order with the same burst time? Now the order is P2 first, then P3, and then P1. See, P1 with the burst time 24, P2 with 3, P3 with 3. Everything is same, burst time is same. We are just changing their order. See the change in their average waiting time and average completion time. Now we will continue this in next class. What if we change their orders from P2, P3 and P1? Thank you.